Question 5. During ultrasound imaging, ultrasound is incident at an angle of 10 degrees in soft tissue onto a plain soft tissue bone boundary. The angle of refraction in the bone is 27.4 degrees. The speed of sound in the soft tissue is 1.54 kilometers per second. Find the speed of ultrasound in the bone. So we usually use the idea that N1 sine theta 1 is N2 sine theta 2. But it can also be useful to express Snell's law in terms of speeds. So if we remember that N is equal to C over V, that is the speed of light, the speed in a vacuum for light over the speed in a medium, then we can get a second version of this which is related to speeds, because we get C over V1 sine theta 1 is C over V2 sine theta 2. If we divide through by C, we could write this as 1 over V1 and 1 over V2, or we could rewrite it as V2 sine theta 1 is V1 sine theta 2. So here the V's and the thetas are sort of mixed up. We get the 1's and the 2's together rather than the 2's and the 1's. So in this particular question, we've got the value of theta 1 is 10 degrees. We've got the value of theta 2 is 27.4 degrees. And we've got the speed of sound in the soft tissue, that's where it starts. So V1 is 1.54 kilometers per second. Now, because we're going to work out a new speed from this, leaving it as kilometers per second is fine. So we want to work out V2. We can see V2 should just be equal to V1 sine theta 2 over sine theta 1. So this is 1.54 multiplied by the sine of 27.4 over the sine of 10. And when we work this out, we should get a speed of 4.08 kilometers per second. This, if we look back at the question, makes sense because this is bent away from the normal as it refracts. Therefore, we should have it speeding up by quite a lot because it's gone from 10 to 27.4, so that increase of speed seems reasonable. The refractive index when the ultrasound travels from bone to soft tissue, so we're going to go back to this idea that N is sine I over sine R. Then we're going to picture that instead of going the way that we've said, it's going in the other direction because it's going from bone to soft tissue. So this is the sine of 27.4 over the sine of 10. That gives us a value for the refractive index of 2.65, the relative refractive index, we should say, of 2.65.